Erection of constant load hangers. In this video, you will learn about the erection of constant load hangers. The constant effort supports deliver a constant supporting effort to the point of attachment of the supporting part. It works like a counterbalance mechanism. The suspended load must be reasonably close to the specified load in the drawing. The constant load hanger should be carefully lifted into its nominated position and secured using appropriately sized fixing bolts or pins. Attachment to the supported pipework is made via the turnbuckle or hanger rod and pipe clamp in the case of suspension type supports, and via the load flange or plinth in the case of compression type supports. The pipework should be accurately adjusted to its correct elevation using either the turnbuckle or the height adjustment nuts. The pipe must be suspended naturally. Sagging or hogging pipework will impose false loads at the support positions. Constant load hangers are sent to the site with the pressure plate locked at the preset position with locking nuts on either side. The locking nuts are red in color to differentiate them from normal nuts. These locking nuts should be in position until the completion of the hydro test and insulation application. If the load on the hanger from the piping system is exactly equal to the preset load, the locking nuts on either side can be easily retracted away from the pressure plate. If the load is not balanced, the forward or the rear nuts will offer significant resistance to turning. If the forward nuts offer resistance to turning, then the constant load hanger load is lesser than the pipe load and needs to be increased. This is done by rotating the load adjustment nut in the clockwise direction when viewed from above for all models other than VU type. Before doing the load adjustment, the pressure plate should be locked in position using the locking nuts, and the load from the piping should be supported using temporary support. If the rear nuts offer resistance to turning, then the constant load hanger load is more than the pipe load and needs to be decreased. This is done by rotating the load adjustment nut in the counterclockwise direction when viewed from above for all models other than VU type. After unlocking particular support, we strongly recommend that the nuts be wound only 2 mm away from the plate. This is simply a precaution to avoid the pipework moving far away from its set position if subsequent supports are not truly balanced. All the supports in a piping system should be balanced in the same way. It is necessary to continually check back to previous supports to ensure that the effect of changing subsequent supports does not alter previously balanced supports. If this is the case, then suitable adjustments should be made to overcome this and return these supports back to their correct position. The process of balancing the supporting system is very much an iterative one. Adjustment to one support may manifest in a change at another 2 or 3 positions away. It is best to work between fixed support positions or terminal points and work towards the center where the piping is most flexible. When all supports are floating, the locking nuts should be backed off fully to allow the system to operate correctly. The constant effort support incorporates a limit stop. The forward, spring side locking nuts will be positioned at a distance from the spring compression plate as shown on the support detail drawing. In the case of constant load hangers, rotating the turnbuckle or adjusting the nut under the load pad in the case of bottom supported hangers only impacts the lever's position and hence the movement. It has no impact on the load. The lever can be adjusted to the preset cold position by rotating the turnbuckle either clockwise or anti-clockwise to move the lever either down or up. In the case of bottom supported hangers, the adjustment is done by rotating the nut below the load pad. In the case of bottom supported constants, the stainless plate that is part of the slider assembly is sent as a loose item to the site. While welding the stainless plate to the bottom of the trunnion or pipe base, care should be taken to ensure that the side with the mirror finish is in contact with Teflon or graphite. Prior to operating the plant, we recommend that all supports are checked to ensure that the locking nuts are fully retracted. No debris has been allowed to fall into the support, especially in the spring housing. The support is free from visual damage, all fixing bolts are secured, and the lever mechanism's rotational path is clear of obstructions. All temporary supports or scaffoldings are removed, and the pipe is free to move as intended in all three directions. We also suggest that a cold survey is carried out and a record of all load adjustment settings and travel scale readings is taken. Standard features: travel indicator with travel scale as illustrated here enables monitoring of pipe work movement and visible from a distance. The hot and cold set positions are marked on the travel scale by means of a red and blue colored washer riveted on the travel scale, enabling visual confirmation of any system irregularities like excess movement, etc. The lever rotation indicator provides a visual indication of the lever's position and whether the hanger is loaded correctly. If the indicator is at the back of the window, then the spring is underloaded, and if at the front, then the support is overloaded. If the indicator is not at the extremities, then support is taking the load correctly. When the indicator is at the extremities, then support load or travel adjustment may be required. A load adjustment facility of plus or minus 20% of the preset cold load of the support is available on the support units. This adjustment can be carried out on-site without any special tools or tackles and without compromising the travel provided. One can read out the amount of adjustment from the load adjustment scale attached to the lever as shown here. Ultimate stop. The geometry of the frame, lever and attachments are designed so that, in case of overload or travel, the lever will be arrested prior to the spring becoming solid, thus protecting the helical coil from excessive stresses. The pipe hangers and supports, constant effort support units, are shipped to the site in the preset lock position as indicated in the contract drawings. The infinitely variable locking or balancing device used for preset locking consists of two threaded rods that run the spring's full length. The locking at the preset position is achieved by locking the piston plate above the spring as shown here. The support then becomes a rigid member. Thus, the locking device is permanently attached to the support and can be used any number of times. Since it is fully threaded, the support can be locked anywhere in its travel range, that is, infinitely variable number of positions. Variable position load pin carrier, as shown here, it is fitted on supports whose total travel is greater than the following values: CA1 120 mm, CB 120 mm, CC 120 mm, CD 160 mm, CE 100 mm, CF 130 mm, CG 180 mm. Once the carrier is repositioned, there is still the plus or minus 20% load adjustment available. By moving the load pin carrier closer to the fulcrum, travel is reduced, load is increased by moving it away, the travel is increased, and load is decreased, thus allowing maximum flexibility in situations where changes are required to loads and travels. This adjustment and flexibility are provided without sacrificing the plus or minus 20% load adjustment facility.